Hello, everybody, welcome to Blue Crypto. Today we will discuss about a new ICO Multivac. Multivac is a next-generation high-performance public blockchain, solving problems of traditional blockchain. So let us first discuss a bit about the problem present blockchains are facing. Recent blockchain protocols suffer from the so-called impossible triangle. It is impossible for a single blockchain to have at once the three desiderata of security, decentralization, and scalability. Largest public blockchains today compromise between the three features. For example, Ethereum is secure and decentralized but are also completely unscalable. The computational power of their entire network is stuck at the level of a single miner. On the other hand, sharding models such as Zilliqa Infinity abandon security guarantees for scalability, and models like EOS abandon decentralization and attempt to solve the performance bottleneck using supernodes. Multivac is proposing a viable solution by general-purpose computation, whole network transactions, and network-wide contract processing in a scalable, expandable, and adaptable way. As I have said earlier, Multivac is a next-generation high-performance public blockchain for industrial-scale decentralized applications. It creates shards from a network of nodes by a probabilistic model called VRF, verifiable random function, solving the problem of how to safely, efficiently, and randomly shard the network. It uses the Byzantine consensus family to reach internal consensus within a shard. It has a special instruction set built into the virtual machine to verify the smart contract's execution. It also has a flexible sharding computation solution which will be very handy for dApps. Let us discuss a bit about verifiable random functions. These are just set random functions capable of generating random values, and the user of this function can provide a proof to parties about the execution of function. Also allow parties to verify it without disclosing the function. It can be used to select bookkeepers as well as to generate validation challenges. Multivac applies VRFs to node selection by using them in sharding process. An amazing feature is a network with a sufficiently large node count has a shard structure, means number of nodes in shard, only dependent on the desired shard size, irrelevant of the number of nodes in the whole network. Let's see how Multivac handles consensus. As I have said earlier, it uses the Byzantine consensus family to reach internal consensus within a shard. For intercoordination between shards, Multivac uses new approach UTXO. Existing sharding technologies including Zilliqa utilize a unified shared ledger. These are able to handle transactions in a sharded network but incur a heavy cost to synchronize the shards throughout the network, failing to optimally solve the sharding problem at its root. Multivac's UTXO mechanism solves the synchronization problem. Each transaction is distributed by the network into different shards according to its account number, such that all the transactions of any given account are executed on the same shard. By this new approach, write operation is only performed on data within the same shard, and that all cross-shard data interactions in the system are read only. So it's less complicated. Problem in UTXO is attacker can hack only one shard to temper transactions or double spend. To prevent this problem, nodes with shards are constantly changed. Also, Multivac additionally makes attacks harder by selecting in node consensus algorithms that will not produce network forks, such as PBFT. Multivac is the first in the industry to provide a computational model for smart contracts which allows developers to flexibly decide for themselves the trade-off between consistency, availability, and partition tolerance, parameters that are often stiffly fixed by the designs of many public blockchains. It was able to achieve so by providing two things. First one is method, to validate the correctness of smart contract executions, and second its general-purpose virtual machine. Let's first discuss about the validation method. POIE, proof of instruction execution is an instruction set-based consensus embedded into the virtual machine, which validates the proper execution of smart contract. POIE is based on physical computational constraints. The basic design principle is that malicious nodes must incur a high real-world physical cost in order to defraud, and that even if they defrauded they would be able to receive a reward but would still not be able to overturn the computation's verified correctness. Many technologies in the world are designed from similar insights. The physical foundations of POIE have some similarity with Ethereum's mining mechanism Ethash. Specially built Multivac virtual machine helps a lot for flexible sharding computation success. Multivac has created its own specialized blockchain dedicated instruction set, the BISC, Blockchain Instruction Set Computer. Multivac also plans to implement an instruction set as a hardware computer. Let us discuss about the team. This is an all-star team from Google, Pinterest, IBM and many world-class corporate house. So we can expect great things to come from them. Yang Jun, Roger Lim, Cheng Chang and many high-profile advisor Multivac has in its project. Also they have partners as Neo Global Capital, which is very encouraging. Thank you very much everybody for listening. I hope you enjoyed the video. Like the video and share with your friends and family.